Hello everyone, welcome to the math learning journey, and here I am with the standard equation of parabola. So let's analyze the math behind parabola. Just have a look on these pictures. They share this shape or the reverse of this shape in case of this picture. This shape is known as parabola. So let's go and analyze the mathematics behind the curve. This is the standard form of the parabola. You can see I have highlighted A, H and K. You will see in the coming slides how these constants affect the shape and the position of the parabola. Apart from the value of A, H and K, the shape and position of parabola depends on its vertex, axis of symmetry and x and y intercept. The vertex is the minimum point in this case, and it's the maximum point in this case of the curve. If you know the value of h and k in the standard form, then the value of vertex will be given by the point hk. The axis of symmetry is a vertical line that divides the parabola into two equal parts. For example, you can observe over here this dotted line divides the parabola into two equal parts, and this is the axis of symmetry. So this line is passing through the point H on the x-axis, so the equation of the line is given by x equals to h. Now, how to find out this axis of symmetry from standard equation of parabola? So you just have to put x minus h equals to 0, which will give you the axis of symmetry as x equals to h. X-intercept is that point on the curve where it passes through the x-axis, as you can see from these 2 points, and y-intercept is that point from where it cuts the y-axis. So since x-intercept that lies on the x-axis, that means for x-intercept we'll have to substitute y equals to 0 in the standard equation, and since the y-intercept lies on the y-axis, so that means to find y-intercept we'll have to substitute x equal to 0 in this standard equation. Let's observe how the value of a determines the shape of the parabola. For a positive a, the curve opens upwards, and for a negative a, it opens the downwards. Now we'll go in little detail for examining different positive values of a. You can observe here this is a parabola, y equals x square, and if you compare it with the standard equation, you can observe that the value of a here is equal to 1. Let's discuss the case when the value of a is more than 1 and consider the curve's equation where a is given by 2. So you can see how this parabola will look like. So that means if the value of a is more than 1, the opening of the curve narrows down. Now let's see the effect of value of a when it is less than 1, and consider this parabola where you can observe the value of a is given by 0.5, which is less than 1. And here goes the green one. You can observe when the value of a is less than 1, the curve's opening widens. So it's interesting to see how the value of a affects the opening width of the curve. A similar explanation can be established for a negative value of a. It is nothing but a reflection of the curve. Now let's examine the effect of value of h on the position of the curve. When the value of h is positive, the vertex of the parabola shifts towards the right. Let's have a look at this example. So in this parabola, the value of h is 0 and its vertex is given by 0, 0. But when we take the value of h equals 5, we get this parabola. You can see the vertex has been shifted from 0, 0 to 5, 0. When the value of h is negative, the vertex of the curve shifts towards the left. In the same example, if I consider h to be equal to -5, I get this particular parabola. So we can observe the initial vertex, which was over here, has shifted towards the left at -5, 0. So we can conclude a positive value of h shifts the vertex towards the right and a negative value of h shifts it towards the left. And now we will examine the effect of k on the position of curve. A positive value of k shifts the vertex of the curve upwards. And a negative value of k shifts the vertex towards downwards. And now it's time to draw the parabola from a given quadratic equation. Let's compare this quadratic equation with the standard form of parabola. On comparison, we find that the value of a is 2, which is positive. That means parabola will open up. H is given by -3 and k is -8. Since the vertex, if you remember, is given by h and k, so the vertex is going to be -3, -8, which is the point right over here. Means this is the vertex. Next we find the axis of symmetry, which is given by x equals h is -3. That means axis of symmetry is again x equals to -3, which is this vertical line passing through the point x equals to -3. So our next task is to find out the x-intercept and the y-intercept. For y-intercept, we will substitute x equals to 0 right here, and we'll get the value of y to be equal to 10. That means the y-intercept is given by simply 0, 10. For x-intercept, we need to substitute y equals to 0. That means y equals to 0, which is going to give a quadratic equation. Solving this equation, you'll get two roots, -1 and -5. That means parabola will intersect x-axis at 2 points, and the points are given by -1, 0 and -5, 0. So with all these ingredients, we are ready to draw the parabola given by this quadratic equation. And here we go. This is how the parabola of this particular standard equation look like. Since the a was positive, the parabola is opening upwards. The vertex of the parabola is given by -3 and -8. You can observe it is passing through x-axis from the point -5 and -1, and it is passing through the y-axis at 10. If you want to know more about the parabolas, you can explore these resources. Thanks a lot for watching this video. I'd love to have your feedbacks and suggestions.